now. As we studied in yesterday's class, types of equilibrium and equilibrium types. Those are absent. I will upload the video on tomorrow. So kindly watch that. So let us see that one of the question which is left in yesterday's class. So there is a given question I already given to you. That is what 12x minus x cube plus y cube minus 3y. So this is the given potential energy. So we have to find it either it is equilibrium or not, and then if it is equilibrium, what type of equilibrium it is. So find the position and equilibrium. Position of equilibrium and also type of equilibrium. So that is what is our question. So find position of equilibrium and as well as also type of equilibrium. So once this question is over, we'll go to the next concept. Okay. So first of all, here it is notice it is two direction, potential energy in two direction. One is in x-axis, another one is in what axis? Y-axis. So yesterday we studied that if it is x-axis means del u by del x, and if it is y-axis means del u by del y. So if it is z-axis, fz is equals to what? Minus del u by del z. So that is what we studied. So only here two things. One is x and another y. So with respect to y, x is 0. With respect to x, y is 0. So that is you should understand. So let us solve now with respect to x. So x means with respect to x, y is equals to what? Everybody. Y is equals to 0. So minus of del u. So u alone you check it. So what is the function? 12x minus x cube. So what is the answer? Anybody? 12x minus x cube. Yes, please check it. 12x minus. So what is the answer will come? 3x square. Integrate. Do the derivation. So what will happen? 12 minus 12x means 12 will come. Minus of x cube means 3x square. Am I right or wrong? Plus. With respect to x, y is always 0. So that this whole function will become 0. Next, same way with respect to y, x will become 0. So minus of del u divided by del y, which is equals to minus of. So minus of, with respect to y, x is equals to what, guys? Minus of, with respect to y, x is equals to what? Respond everybody. 0. Am I right or wrong? Yeah, 0 plus. Now next y. What is the y? Y cube means what is that? Yes, please. Y cube means 3y cube minus 3y means what? Speak Ra. 3y means 3 will come. Differentiation not saying, nobody. So 3y is
3.
right or wrong? 3y square. Sorry. So this is 3y square and this is minus 3. So this is what about x and as well as y directions. So now, so we all knows that everything force is equal to 0. Then first this one what it will become? Minus 12 plus 3x square is equals to 0. Am I right, Rudreswa? This is whole minus. So 3x square is equals to 12. X square is equals to 12 by 3, which is equals to 4. So that x will become what? X is equals to root 4. So plus or minus 2. So either plus 2 or minus 2. Am I right or wrong? So we all knows that net force in every direction is equals to what? X direction equals to 0, y direction is 0, and z direction is equals to also 0. So that's all. Same way, if I take Fy. So Fy is equals to 0. Tell me what will happen? Only 3y square minus 3 is equals to 0. So 3y square is equals to 3. Y square is equals to 3 by 3. 3 by 3 means how much? All of you? 1. And
1
equals to what? Plus or minus 1. So either plus 1 or, yes please, minus 1. So totally two different directions, x-axis and y-axis. So x point is, if x point is plus 2, minus 2. Y point is plus 1, minus 1. So totally how many points will come? Everybody check it. If I take plus 2. So what is the first point? Plus 2, plus 1 will come. X and y axis. Or plus 2. Everybody respond. Plus 2, minus 1. So 2 points. Minus 2. So what will happen? Minus 2. Yes, please. Plus 1. or next one -2 -1. Am I right? Totally. So totally how many points it will come equilibrium? Everybody. Yes, please. 1, 2, 3, and 4. So totally how many points it will come to equilibrium? All of you? 4 points of equilibrium. So the body will comes to the equilibrium 4 different points. So if you want, we can let us plot the graph for this. So if I plot the graph for this one, so what will happen? First A point. So what is A point? +2 +1. So +2 means X and +1 means Y. So this is the point. Am I right or wrong? Everybody clear? All of you? So this is the point A, yes, which is what 2, 1. Same if B point, tell me this is A and B and C and D. B point 2 -1. So 2 in x-axis and -1 is in y-axis. Means in the sense of here the B point will come. Am I right or wrong? Sorry. 2 and 1. Sorry, 2 and -1 here. -1 is -1 here. So 2 and -1 means it will come here. Am I right or wrong, guys? Please respond. 2, -1. Same way next, -2 +1. So -2 means this is -2 +1. So means the C point will come here. This is C point -2, 1. Last one, -2 -1. So -2 -1. So means the D point will come here. So this is what about -2 -1. So these are the 4 equilibrium points. Am I right or wrong, guys? All of you? Yes, please. So now at every point, so we found that totally how many points it will come to equilibrium? 4 different points. So now in these points, either it is stable or unstable. That is what we should find it. So let's start finding now, everybody. If you want to find stable or unstable, we have to go with the what? Second time differentiation. So that is what double differentiation we can say. So what we have to do it, guys, now at point A. So let us verify at point A. If you all observe that. So point A, if you check it, what is the point A, everybody? D square U by dx square. So if you have done that x. So what is the D square U? Check it, everybody. X. X point I'll verify. Y point later I'll verify. Because X point, what is X point, guys? This is X point. So X point, check it, everybody. A point, what is that? Fx equals to differentiation. 12 minus 3x, sorry. 12 minus 3x square. Am I right or wrong, guys? Du by dx. So if I do the double differentiation, so what is the answer will come? Fastly. Everybody. Yesterday, these many things we have done. So which is equals to 12 minus 3x. Am I right? 3x square. So divided by dx, which is equals to what will happen? Constant is 0. So minus of 3 into 2 into x. Am I right, guys? Which is equals to minus 6x. Yes or no? So x value. So what is the x value? X value is at A point what? Open your mouth, simplicity. X value is how much at A point? 2. So if I substitute 2, so it is minus 12. Minus 12 is less than 0. So U is what? Less than 0. So U will become what? Maximum. So means it is unstable. It is unstable. Same way verify at the same A point. What about the Y point? Y axis. So A point at Y point. You can check it. So point A, Y point. So what is that? D square U by dy square. So which is equals to again minus 6x. Am I right or wrong? Minus 6x, sorry. Yes, no. 6x not. Y we have to verify. So Y, what is the function? Verify. What is the Y function here? Check it, everyone. 3y square minus 3. So 3y square minus 3 means constant will become 0. So what is the answer will come? 6y will come. Am I right? 3y square minus 3. So divided by dy. So double differentiation this is. So this will turns into what? 3 into 2 into y minus 0. Constant it is. So this is not required. So totally how much will come? 6y. So 6y means 6 into y value is how much? 1. So which is equals to 6. 6 is greater than 0 or less than 0? Greater than 0. So means U is what? U is minimum. So that stable or unstable? It is stable. Clear, everybody? Stable. So observe very carefully. At point A itself, what does it mean? At point A itself, x-axis is unstable, y-axis is stable. What does it mean? What do you mean by stable or unstable? Yesterday we have studied that. If you take a ring, so what do you mean by stable? If a body is disturbed somewhat, it will go to this position and it will come back to the what? Same position. So if it will come back, that is what we used to call as stable. Am I right or wrong? Everybody? Yes, sir. Yeah. So means here I am saying at a point, X-axis, it is unstable. Means in the sense of what? It is going, but it is not coming back. Suppose if I disturb like this, it will goes, but it will not come back to the what? Come back to the same point. Understanding? But in Y, if I take it for example somewhere up, again that will come into the what? Same point. So that is why at Y point it is stable, and X point it is a what? Everyone? Unstable. Understand? So X point, the body is not coming back to the same position. But Y point, if I take it, if I disturb it and if I leave it, again it will come to the same point. That is what it is, stable equilibrium. Is that understand everybody? So like every point, if you come to the C point, you can verify. If you come to the D point, if you come to the B point, so you can understand X-axis, either it is stable equilibrium, or Y-axis, it is stable equilibrium. You can verify for B point, C point, and as well as D point, all the 4 points. So totally we found 4 equilibriums. At every point you can verify either it is a stable or unstable equilibrium. By doing what differentiation? Double differentiation. So one already differentiated, so we'll get this function. So minus, irrespective of minus, this minus is for only this one, okay? That is for work done. So irrespective of that, if you do that, this one double differentiation, you will get fx, double differentiation of x. This is y, it will get it. Do you understand everybody how to do it? Please respond, all of you.
Yes, sir.
So that is what. You can find the stable or unstable equilibrium for all remaining 3 points. If you are interested, you can go ahead with that. Okay. So hope everybody clear. Anything doubt, you can ask me. Understand, Mr. Pradosh? Kudreswara?
Yes, sir.
So this is what
Yes,
is
sir.
about equilibrium and types of equilibrium. Now today's class we are going to study. It will be more even complicated. So as clear as possible, I will try to explain. The concept will be very tough, but the thing is, it's very important. It's very, once you catch the point, it will be very easy. So that's what we are going to study, conservation of energy. So particularly mechanical energy. So you might be studied mechanical energy means 9th class. What is that? So it is a combination of 2 energies. Anybody? If you add 2 energies of a body.
Kinetic energy and potential energy.
So conservation of energy, particularly mechanical energy. Okay. So the only mechanical energy alone we are going to study. So you know that mechanical energy will represent with a E. All of you remember in 9th class, class 9th, you might be studied that mechanical energy of the body is composed of 2 things. One is kinetic energy. Another one is what, guys? Potential. Yes, please. Potential energy. So sum of the kinetic energy plus potential energy is only equals to mechanical energy. Understanding all of you? Yes. So we are going to derive the formula for conservation of energy. Okay. So you might be studied in 9th class. Work energy theorem. Do you all remember work energy theorem? Everybody, anybody? So work energy theorem is equals to, it will says that the total work done by a body which is equals to change in kinetic energy. You might be remember this one. Means in the sense of final kinetic energy minus initial kinetic energy. So you might be studied by the time this derivation also. Am I right, everybody? The work done, the total work done by the body is equals to change in kinetic energy. So this is what you might be studied work energy theorem in 9th class. Of course, that is also we are going to study here. But the way of solving is different. And now I am saying we are going to study conservation of energy. Which energy it is, everybody? Mechanical energy. So mechanical energy means it is a sum of potential energy plus sum of potential energy plus kinetic energy of the body. So that is mechanical energy. So remember, mainly in this class, we are going to study the problems related to spring related problems, and as well as incline related problems. Mostly in our today's class, we'll study spring related problems, and then tomorrow we'll study inclined related problems. So spring related problems alone, how to solve it, and we have to prove that the energy, mechanical energy is always remains conserved. That's what it is. We have to do it. Now to derive that, first we have to prove. So as I said, this what work energy theorem. So let us start with that and we'll proceed. Okay. So now all of you said, so as we studied, we are going to study only spring related problems. So all of you observe very carefully. I will draw the diagram. So let us take the surface, rigid surface, and there is another rigid surface. Okay. So please observe very carefully. So now there is a spring actually from this, and some mass has been kept. So this is what it is, M. What is the mass of the body? M. Now all of you observe. Let me tell me what are the forces acting on this body. Anybody can tell me, please? First thing, we
Sir,
all
weight
know,
and
of course, weight of the body is which is acting downwards. That is what force of gravity. Am I right or wrong? Yes. And this surface will
sir.
exert force opposite direction. What is that force we used to call, brothers? Force exerted by the surface, which is called as normal. Correct? Everybody?
Yes, sir.
Yes. Now, if I apply the force from the top, I used to call something. What is that called as? F external force. Am I right? Everybody?
Yes, sir.
Yes. So if it is next, it is present in the spring. So the spring also will exert force or not,
Spring
upward
force.
direction. Yes, that is what
Spring.
external force. Now, observe very carefully. Is this body is coming downwards. So here, kar sound is coming. So that doesn't mean that. What does it mean? Anybody? Yes, please. There is a force. If the body is moving downward direction, sorry, body is moving forward direction. So there is a force which is acting backward direction. What is that? Forgot it. Force of body is moving forward direction. So
Friction,
the
sir.
force of
Friction.
friction, as it is attached to the wall. So that here force of friction will be there. Am I right or wrong? Everybody?
Yes, sir.
So because
Yes, sir.
the surface is a what surface? A rough surface. So if I consider rough surface, so what is that, everybody? So definitely there will be friction because this body is trying to go down. So that always there is a force which is acting upward direction, opposite to the direction of motion. What is that force, everybody? Yes, please.
Friction.
Yes, frictional force. Now, if I take the FBD, so FBD means check it, everybody. How many forces are acting? So F friction is acting upward direction, and F external is acting downward direction, and the spring force is acting upward direction, and the normal force is acting perpendicular to the surface, and the weight of the gravitational force is acting downward. So these many forces are exerting on this body. Will you all agree with me, everybody?
Yes,
Yes.
sir.
So that is what. So these all the forces we used to call something. What is that? Net resultant force. So net result according to the Newton's second law. What is net resultant force is equals to? From Newton's second law. Everybody respond. From Newton's second law, what it will say is F net is equals to what, Ra?
acceleration.
Yes, F is equals to ma. What F net? F net means this all the forces. So sum of this all the forces. What is that? F external plus F frictional force plus, sorry, spring force plus, F gravitational force plus, F normal force plus, F frictional force, which is equals to mass into acceleration. Will you all agree with me, everybody? Clear? Yes, please respond, everybody. Now, so we all knows that from the second chapter, acceleration is equals to, anybody can tell me, dv by acceleration is equals to fastly. Mr. Narayan,
Everybody.
yes, Monish, everyone please involve in the class and speak. Whatever you know, speak, right or wrong, speak.
Mass.
So dv by dt.
DT.
So now I will use numerator and denominator multiply
dv
dx by dx. So what is another formula of acceleration? Anybody can tell? So
v into dv by
yes,
dx.
we all are very
dx
familiar
by
with that. So dx by dt will become velocity. So that dv by dt, understand? Sorry, dv by dx into v. Am I right or wrong, guys? This is only I can write.
Yes, sir.
V into dv by dx. Is it all? Will you all agree with that? Everybody clear? So these all the forces we used to call as F net. So F net is equals to M into V means what? V dv by dx. Is it clear, everybody? Yes. Now dx will come this side. So what will happen? F net into dx, which is equals to mv dv. Clear, everybody? Now apply the integration concept. All of you apply the integration. So force into displacement, something it is. Force into displacement is equals to something. What is that?
Done.
Work done.
Work done.
Can I write it or not? This one, which is equals to total work done. Am I right? Please respond, guys.
Yes, sir.
Which is equals to mass
Sir.
of the bodies remains constant. M I will take it outside. So V dV. So integration of V dV formula. Integration of x dx, which is
V
equal
square by 2.
yes,
X
square by
x square by 2. V
which
square.
will turns into M into, which will turns V square by 2. So what is that range? Final initial velocity to
Initial velocity to final velocity.
initial velocity to final velocity. So I will take the 2 outside. It will turns into M into M. So V square initial velocity to final velocity. So what is the formula will come, everybody? So work done is equals to F net, total work done, net work done is equals to half into m into this one, what will happen? V square minus u square. So
U
which is what I
square.
can write? M into V square minus half m into u square. So this is only ways to called as total work done, net work done. So this is only ways to called as what? Anybody can tell me? Work
energy theorem.
theorem. So, but ninth class we used to study simply. Okay. So that's all it is. Now, if you want, you can verify. This fully is equal to something according to the last class. Anybody can tell me? We have studied already this one. So this is what? Final kinetic energy of the body. Am I right or wrong? Yes. Minus. This one is what? Initial kinetic energy of the body, which is equals to what? Work done. Okay, understanding all of you? So this is what? So this is the one which is always 100% true for every substances. It is always, it is true. Is it clear, everybody? All of you? Yes?
Yes, sir.
Yeah. In particular cases, there is another force which is actually fake force. That is also included. What is that? Anybody can tell here?
Pseudo force.
Yes. So of course the pseudo force is also included, but here it is not valid. We are not considering as a pseudo force. Pseudo force is also included along with the F external, F net resultant force. But here we are not considering pseudo force. So we are excluding the pseudo force and we are writing only F net is equals to external force plus spring force plus gravitational force plus normal force plus frictional force, which is equals to MA. Am I right or wrong, everybody? Yes, please.
Yes, sir.
Yeah. Now observe very carefully. In this, all the forces, one force is zero. Be smart and tell me one force is zero. Can you tell me what is the force is zero? In this, all the forces. Of course, I can consider external force. Maybe it is applied force is zero. I'm not talking about external force. You tell me some other force. What is that force which will become zero? Anyone? Some force, if you observe this picture, some force will become zero. The angle between them is 90, so that the force will become zero. Anybody can find it? Check it, everybody. There is a force. Observe all of you. So there is a force which is acting like this. That is what? Normal force by the surface.
Normal.
Yeah, and the displacement of the object is what? Downward direction. Am I right or wrong? Everybody. So what is the angle between them? 90 degrees. So 90 degrees means what is the work done? Work done by the normal force. All of you.
Zero.
Work done by the normal force is what? Into cos 90. So that what is the answer? Work done by the normal force is equals to
Zero.
0. Okay. So who is that sound? Just see a second. So work done by the normal force. How much? Rudreswar Purima Purila. Understood?
Yes, sir.
Yes, that is what. So I will say, so we all knows that total work done. So total work done is equals to work net is equals to final kinetic energy minus initial kinetic energy. So we all knows that total force. What is that? External force plus spring force plus gravitational force plus next normal force plus frictional force, which is equals to M into A. Now in this, I have found that net the work done, the force applied, that is what? The work done by this one, which is equals to what? Work done by normal force, which is equals to what? 0. Because normal force and displacement both are what is the angle? Everybody. The angle between them is 90 degrees.
90.
Understand? So that's gone. Now, the spring force and gravitational force, both we used to call something. Anybody can tell? Previous lectures, if you remember, you can make it easily. Both together is an example of something. What is that?
Conservative.
Conservative.
Yes, conservative forces. And force of friction is a what force? Yes, please. Example,
Non-conservative.
non-conservative. That's what every lecture has a connectivity, conservative and non-conservative. Okay, so that's all it is. Now you can see this together. I can take the total work done is equals to work done by external force plus this together, work done by conservative force plus this one, work done by non-conservative force, which is equals to final kinetic energy minus initial kinetic energy. Any doubt for anybody? You can ask me. Are you clear, everybody? Yes, please. All of you. Now, work done by conservative force, you send this side. So I will write work done by external force plus work done by non-conservative force, which is equals to final kinetic energy minus initial kinetic energy. This plus work done by conservative forces will come this side. What will become? Please respond. All of you. Minus work done by conservative forces. Am I right or wrong? So till yesterday's class, potential energy, those who are remembered, can you tell me? Minus of work done by conservative forces is equals to something. What is that? Yes, please respond. Change in
Delta work.
yes, delta U. Delta U is equals to minus work done by conservative forces. We studied or not, everyone? So what is
Yes,
delta?
sir.
Final potential energy minus initial potential energy is equals to minus work done by conservative forces. So instead of minus work done by conservative forces, can I write final potential energy minus initial potential energy? Everybody, will you all agree?
Yes, sir.
Yes or no? Please respond, others. Okay.
Yes,
So now I will write Kf minus Ki, final kinetic energy minus initial kinetic energy. This whole thing I will write as a plus what I can write? Change in potential energy. So the final potential energy minus initial potential energy. Is it okay, guys? Please respond. All of you?
yes, sir.
Yeah. So now here I can do something. Anybody can tell what I can do it? So this both. So work done by external force plus work done by non-conservative forces is equals to this can I write as a final kinetic energy minus initial kinetic energy plus final potential energy minus initial potential energy. Will you all agree with me?
Yes, sir.
Yes. So now I write this one as a final kinetic energy plus final potential energy bracket minus of both minus is common and can I write a initial kinetic energy plus initial potential energy? Will you all agree with me? Everybody. So which is equals to work done by external force and work done by non-conservative forces is equals to this one. Do you all understanding all of you? Please respond. Everybody. So this is even the more better formula for what? Conservation of what energy? Conservation of. Yes, please. What is our topic? Conservation of
Mechanical.
Mechanical energy.
This is a more even better formula for conservation of mechanical energy. Now, the sums, 90% of sums, of course, almost 80 to 90% of sums, which will come in our exam, and for you, 11th class, 80% of external force is zero. Means external force is absent. Means in the sense of, if external force is absent in the sense of, okay, so what do you mean by that? Work done by the external force will become what? Everybody. Work done by the external force is equals to what? Zero.
Zero.
And 80% problems, they will be provided you smooth surfaces. What do you mean by smooth surfaces? No roughness.
Frictionless, sir.
No friction, sir.
No rough.
friction.
Understanding? No roughness. Mr. Narayan, are you understanding? No roughness means friction is equals to what? Everybody. Friction is not equal.
Frictional force is equal to zero.
Means in the sense of work done by non-conservative is also what? Everybody.
Zero.
Zero, sir.
Work done by external is equals to zero. Work done by non-conservative is zero. So means in the sense of equation will be modified into 0 plus 0 is equals to final potential energy plus kinetic energy plus initial potential energy and minus of initial kinetic energy plus initial potential energy. So this whole term, this minus will come this side. It will become what? Everybody plus. So
Yes.
initial kinetic energy plus potential energy, which is equals to final kinetic energy plus final potential energy. So this is only what? So therefore, initial energy is equals to final energy. So energy is conserved or not? Fastly. Energy is
Yes.
conserved. So that is what? Which energy? Mechanical.
Mechanical energy.
Check it, everybody. Mechanical energy is conserved or not? Kinetic plus potential, which is equals to potential again kinetic plus potential. So I can say the initial mechanical energy is equals to what is that? Final mechanical energy. So I can say this is only we can say what? Conservation of. Yes, please. Conservation of what energy?
Mechanical.
Understanding, all of you? Laksha, Aswita, Manya and Samya. So this is what is about conservation of mechanical energy. I hope you all understand. Anything doubt, please let me know. Clear, everybody? Sudreswa, Pradosh?
Yes, sir.
And what? Pradosh? Mr. Narayan? Sai Garvin? Yeah. Understand, Pradosh, how to make it? So mostly
Yes, sir.
90% cases you will get external forces absent and as well as smooth surfaces means work done by external forces as well as work done by non-conservative forces, both is a zero. So that we can say initial mechanical energy equals to final mechanical energy. That's all it is. Prove. Okay. So question number 1. That's all about the concept. I hope everybody clear. So now, so there is an object. You can notice it. It is falling freely. So falling freely towards the ground. So means in the sense of it is frictionless surface and external force is also 0. So keep it in mind, all of you. Now I will say you 2 formulas. So this is one formula. Okay. And this is another formula. This is also one of the most important formula. You have to use this formula when external force is present or work done by what? Non-conservative forces. Means when the given there is a friction, if the friction is existed, you have to use this formula for conservation of mechanical energy. Understanding that? Please mark it. If there is no external force, that is what? If there is no non-conservative forces, then which formula you have to use it for numericals? Everybody, this formula. Clear? If no work done by external force or no work done by external and work done by non-conservative forces, this is what is the formula we have to prefer. Is it okay? Mr. Monish, I'm speaking. Mr. Murali, no response at all. So if the external force work done or non-conservative force work is there, then you have to use which formula? This is the formula. Is it okay, guys? 2 formulas totally. Understanding all of you? Everybody? So now,
Yes, sir.
freely falling body whose mass is m, falling from the, of course, it is freely falling means initial velocity is what? We all people know. 0. And is traveling a
0.
certain height h, and this is the initial position, and this is the final position before touching the ground. Our task is to find what is the velocity which it will strike the ground. That is what final velocity. So now there is no friction, there is no external force. Then tell me which formula we have to use? First formula, second formula. Make it quick. Second formula. Understand? So final kinetic energy plus final potential energy is equals to initial kinetic energy plus initial potential energy. Now tell me, what is the initial potential energy? Now I will say you 2 formulas. Half
Formula.
equals to kinetic energy, potential energy, gravitational potential energy formula. Speak loudly. mgh. Yes or no? And spring potential energy formula what? Half kx square. Am I right or wrong? Sorry, spring elastic. Yes or no? Spring energy. SP, the force exerted by spring half a kx square. Yes, Rudreswa? Remember, this is energy formula, potential energy formula, and spring force formula, half kx square. I think you have written already. We have written or not? Change in position, kx2 square minus kx1 square. Change in the spring force. That is what?
Yes,
Yeah, that is what. Please remember that. Now the body is freely falling. So now you tell me initial velocity. Now before that self 9th class concept I am saying. Kinetic energy is due to motion. Keep it in mind, due to motion. Potential energy is due to state or position. Okay. So if any body is on the ground, what is the potential energy? Anybody? At the ground, potential energy is equals to what? 0. So keep it in mind that.
0.
Okay, ma? All of you. So now if the body is freely falling, so what is the potential energy poses top or bottom? Anybody? Yes, please. Top or bottom?
Top.
Top. So that is what final potential energy is what? I will say final potential energy equals to
0.
what? 0. Initial potential energy is equals to what? mgh. And same way, initial kinetic energy is what? Initial kinetic energy. It is at the rest. At the top, it is at rest. So initial potential energy is what? 0.
0.
Final potential energy before
0.
touching the ground. What is that? Half
Half
mv square. That's all it is. So now we have to find velocity. So that check it everybody. So both the sides of mv square is equals to mgh. So mm will get cancelled. We want so v square is equals to 2gh. So v is equals to what? Everybody? Root over 2gh. This is what equations of motion. Third equation of motion also we're using this in 9th class and we'll solve. Am I right? Gravitation chapter example number 3. We'll solve like this only. So v is equals to root over 2gh. All of you understand how to use it, everybody? Clear? Please respond, everyone. So that's what it is. So you must understand. If you're not understanding, it is very tough to make it. Okay. Next question number 2. 1 or 2 questions you might be confused. Later you will be understand very easily. So observe very carefully. There is a spring. There is a spring whose mass is attached. The m mass is attached. So it is at beginning. So having a spring constant k. Having a spring constant how much? K. Now, after certain time, it will attains to the equilibrium. Attains to the equilibrium means definitely there is a extension. Am I right or wrong? Yes,
Yes,
please.
sir.
So there is a extension. Body attains to the equilibrium. So definitely there is, if you notice it, definitely there is an elongation. So let me take the distance is how much I can take. Yes, please. The distance I can
X.
take the what? X. All of you understanding? So it is allowed to freely fall. It is allowed to fall. Allowed to fall. Find the elongation of the spring. Clear, everybody? Elongation of spring. That is what is our question. So options also I'll give. Meeting is going to end. Please join fastly and make it. Option A, mg by k. Option B, k by mg. Option C, 2 mg by k. And option D, 2k by mg. So these are the 4 options. So please make it and we will see that. Okay. So all of you observe very carefully. Now, if the body is, if you consider this is the baseline, if this is the baseline,